I had a kid at the Rockwell last night get very impressed that I had YouTube. I'm like, dude, it's 2018. I think everybody has a YouTube. Like, if you have a Gmail, you have a YouTube.
Yeah.
Like,
I have a YouTube, it's just that I posted like really stupid stuff.
No, you
yeah.
don't.
Alright, so we need to install a fence. Simmer down now. So, anyone want to read 5104 for us, or are you going to have to listen to me? Marvin, kick us off. Hey people, we all need to hear this, and Marvin's doing us a favor by reading it for us. Can we like turn it? There's a lot of information here, right? Grant.
I have a question. Are we still checking, even though we don't have classes, are we still checking Wednesday's homework on Friday?
Because I won't see it. I won't have an opportunity, so our next homework check will be next week. Either Monday. Depends on how the schedule pans out and what classes and have some extra time to look into it. So, your task with your partner or partners. Determine how much fencing will be used on each side of the court and be prepared to justify your answer and show all of your work. So I'm going to cycle around. Mr. Smith might cycle around. If you have questions, raise a hand that you are using that resource page in front of you. I do not want to hear a question unless you've already asked it to your partner. So if you have a question in your mind, ask your partner before you think about raising your hand. Because even just having that mild discussion can activate things in your brain. Just saying it out loud, it can activate things in your brain. So have at it, dive in. Let's see what we think. We got 183 feet of fencing, 3 sides, all that information in comparison. So, as you dive into this and you're looking at your resource page, depending on how good you are at, where's my camera? All right, never mind, keep working. We're going to talk about the 5D process, but I don't know why my camera's not loading up. So the 5D process described on your resource paper says describe and draw. So it tells us the shape is a rectangle, but we are only looking for 3 sides of it. And this problem is about perimeter, right? Distance around. And we know that one side will be 5. One of the widths will be 5 shorter than the other one. I don't know. This is really not going to work well unless this, there we go. There we go. If it doesn't work, unplug it and plug it back in. Alright, so here's our 5D process. Everybody has this paper, right? You are going to use the 5D process like the entire rest of your time in CPM math. Because really, when you start a math problem, having some kind of model or formula, and I'm not talking like an equation, but a method that you're going to process through is a really good, every time I approach a math problem, I can think through this process. So can we, or how do we, describe or draw it? So they have done it for you, right? Or is this different in your resource page? Okay, great, making sure this is the same. So they've drawn it for you, right? Side 1, side 3, they told me are the same there. Then side 2, we're going to miss 5 feet for the gate. Total fencing is 183. What's this 32 here? Alex?
The side one, the is the length.
Okay. So if our total fencing is 183, we are trying to make all sides that we show fence on add up to 183. They try a couple different options. So it is started for you. This is kind of like guess check, but a bit more detailed. So they say, what if side 1 is 10? So then side 2 is the same as side 1, but take away 5 feet. So they determine side 2 by 10 minus 5, so that would be 5. And then side 3 is 32 feet longer. So they say, all right, well, 10 plus 32 to make this whole side makes 42. And they add all 3 up. Does that use all the fencing that they have? Not even close. And guys, think about only a 10-foot wide basketball court. That wouldn't work very well. So they then try 20. If side 1 was 20, what would side 2 be since it's 5 feet shorter? 15, which they tell you right here. So I'll make those little bars drop away. 15. If side 3 is 32 feet longer, it would be 52. They add them all up. It still doesn't work. Your job is to make a better way to do this. This guess check method could take us all day long. So how could we use variables to make our life easier here? Work with your partner to try to figure out how we could use variables in this situation to make this work easier. I'm going to give you probably at least 3 minutes. Guess check is going to be real tough. Because what if it's not a whole number?
I tried it once.
Yeah. If side 1's going to be a length that we don't know, but they keep referencing side 1 as like where we start, what could we do for it? Alex? Call it X. So if we call side 1 X, what would we call side 2? Really get cards out. Grant?
X minus 5.
Why?
Because we can't solve the common. This is a variable. So we only can use
Why the minus 5?
oh, because there's a small gate.
The gate, right? So this side's the same as that side, except for the minus 5. Then think about, I'm not going to give it to you, think about what we would...
Good morning, Annika Daly. Please come to the office.
I
Annika
just
Daly,
got
please
you
come to the
back.
office.
And they're going to take you away
I
again?
just got her back too.
What would side 3 be? Are you leaving? Oh, well, you look like you're packing up. So, up here, what would side 3 be? We're not going to give it to you as a class. Then set up an equation to try to match this situation. We know that we're going to use 183 feet of fencing. That side, and that side, and that side. 183. opportunity. This paper we're probably not going to use today. This is for future 5D processes. So this is like hang on to it sort of thing. You can fold it in half, keep it in your journal because it won't fall out, or keep it in your binder. It's punched for you. Delaney, what would you call your third side? The top as it looks here. Well, we already called that side X, and I agree that this part is X, but the whole amount of fencing X. So that 32, I don't know if we could hear Alex earlier, that 32 is that distance, because they tell us the court's 32 feet longer than it is wide. So if we know that, like, hey, width is what it is, and then we can reference width when we go to figure out the length, but then add 32, we would just say X plus 32. How can we then work with this equation? We need a little bit more time to try to figure this out, see if anybody can get it. Well, it says it right there. It says that they were guessing. They were guess check. So they kept getting too small, right? So we could have guessed 40 to 50. But we could be here all day. So instead, we're going to think a bit more strategic. So if you have X, why did you say X minus 5 plus what's the third side? We just said it. So we would put plus X plus 5. Then see, can I add that stuff together? Can I combine some like terms? Please make sure we're filling this out on our resource paper. What goes here in my side 3 column? You got to just shout it out.
X plus 32.
X plus 32. What goes in this parentheses over here?
X plus 32.
X plus 32. Sorry, that's a 32, although it barely looks like it. What values, keep going cards, Francesca, what values over here in the do column can I put together? Are there anything that I can, is there anything that I can combine? Yeah, this side, and this side, except for we take away 5, those are all the same lengths. So the X, and the X plus X gets you what? All right, banana plus banana plus banana, what do I get? 3 bananas, so we have 3X. Trying to make life easier. Now I still have a minus 5 and a plus 32. Can I put those together? And what do I get? 32 essentially minus 5 gets us 27. Very good. And that's equal to 183. Needs to be. What we're saying is this section plus this whole section plus this section without the gate, because they're going to buy the gate separately, is 183 feet of fence. How can I figure out what X is? This is just like our cookies yesterday. Our boxes of cookies. It's fine, guys. Gravity works. Keep moving on. How? You're good. Take care. How do I deal with this to try to get X by itself? Yeah, Alex?
Take away 27 from each side.
So I'm going to move this up a little bit. Why are we doing that, Alex?
So it's just 2x equals 3.
So I'm worried that some of us aren't paying attention. We're just going to write stuff down without knowing why. Alex is talking us through. We're going to take away 27 from both sides, because I can't join it with the 3x, and I want to solve for x, so I need to get this by itself. Start getting rid of other pieces. Now, some people, and this would not necessarily be wrong, but not necessarily be right, would try to divide by 3. You could, but everything would get divided by 3. So even the 27 and the 183. So it's easier to subtract the 27 first. So when we subtract 27 from both sides, please write that out. We're going to get 3x is equal to what? We're not 156. What does that tell us? What is 156? If we look up at our picture. The total of those 3 bolded sides, right? This side, this bold section, and that side, without the 32, without the 5, those sections are 156. How do I figure out what each of those sections actually is? How do I get there, Marvin? Yeah. We divide by 3 on both sides, and we get that x is 52. 52 what? Feet. We should have talked a little bit about labels in foundations. Now, if x is 52, we still have a little bit to solve here. So I'm going to pop back out of this camera. Back over here. Trying to see if I had it formally put in here. What else do we still not know? If we look at like this image, what is the 32? Who can make sense of what we just did? Who that isn't Alex? Raising his hand for everything. About Penelope, what do you think? What is the 52? Sorry, not 32. What is the 52 that we just found? Yeah, and that, if we look at this picture, would be up here, right? How do I figure out this length between the wall and the fence, Nathan?
Subtract 5.
Subtract 5 from my 52. So what do I get? 47. Careful there. How do I get the length of the fence for the courts? Patrick?
57 plus 32.
52 plus 32. Be careful. So 52 plus 32. 84. Then we could check. Does that, those 3 values, does that add up to 183?
Yeah.
And it does. Now, we took a while on that problem, so we're not going to do a team switch. But ask yourself, if somebody else, if another team, not your teammate because they sat beside you, but if another team looked at your work, would it make sense? Did you show when we took values away from both sides? Did you show when you did the division? If you're not writing this stuff out, it won't make sense when you come back to it. Okay, we need to write out the process, write out your steps. Okay, so we're going to skip over 105. So when we look at the resource page, they had done guess check kind of techniques, right? I'm actually going to pull my sheet back up. We're going to start using this process a lot. What is a trial? You guys are working on science fair right now. What is a trial? I'm going to put my sheet up here. Like when they hear trial 1, trial 2. Aubrey?
It's kind of like how many times you're going to do it.
Yeah, but
Like
what?
how many times you're testing something.
So a trial is like a test, right? Here they were testing, would 10 work? Here they were testing, would 20 work? Now what Why is this called define? Like, I hope we understand the describe do, or describe draw. We just make a model, explain what it is that we have. So we made that model. But define, what did they actually do there compared to up here? Here they drew a picture and they showed the information, but here they formalized it. The define just makes it mathematical. We write it out as expressions, right? So instead of showing, okay, this fence is going to miss 5 feet, they write out my fence length minus 5. Instead of showing, and I feel like some of you are crooking your neck up, they try 20, right? Still in the define, and my one side's 5 shorter, my one side's 32 longer. We're defining these things. But then we realized we could work this more easily with variables. I would always encourage you, try to use variables and algebra as opposed to guess check. Guess check, we could have been here all day. There was a thought in the back of my head to just have you guys guess check until somebody figured it out. But we would have needed a guess check until we found the answer of 52, and that probably would have been a little awkward. You'd go high and then lower and then higher, and then like you just kind of work your way down to there. So then the do, we actively try to put it together and get what we're looking for, and then decide, did it work? Did our method using the algebra work? Did we find an answer? Yeah, so it totally worked. And declare, we're going to come back to this more with future problems, but the declare section, we can really declare how we got it or what method or what our solution is. So here in our declare section, we just had our declaration of our short side, our short fence for our width being 52, because we found our correct value. So declare is kind of like where we state our answer. So if we were working through this, and we were working through guess check, and we tried 30, and we got 117 feet. So let's say we kept going with their method of go up by 10, up by 10. We tried 30. It's still too low. Talk with your partner about what you would have tried next, and how long you think it would have taken us to get there. I kind of went rogue with this lesson because I wanted us to process through it. What would you have tried? So Marvin said 50. I'm going to pop around there. If 30 got you 117, actually throw that on your paper. On your paper, if you've got space left, let's put in here that if we did 30, I don't know if you guys took as much space as me. If we tried 30, this would be, what would our side 2 be?
30 minus 5.
30 minus 5, so 25, right? And side 3 is 30 plus 32. So 62. So that, and that, and that. They tell us it comes out to be 117, right? Still too small. So I skipped over that section that I had covered. Would you have tried 40 next? Because they went 10 and then 20 and then we went 30. Who would have tried 40 next? I won't put people on the spot. I probably would have tried 40 next. Who would have realized that my jumps, what's this jump go up by? 30 feet. What's this jump go up by? 30. Ooh. So wait, what do we notice here actually? So you said this went up by 30. What's this do? Patrick? It goes up by 30 also. What happened here? Up by 10. What happened here? What could we say about what we see happening here? Grant's whispering. Alan, what do you think? What could we say about what's happening here? Compare like what we did with our side 1 compared to what was happening with our total.
It's proportion.
How so?
Because it's going at the same rate.
So as my side 1 goes up by 10, we could then say the total, put it together, no, maybe. I feel like we're struggling today. Who's like tired? Who's like, this is our first 5-day week back, and we're like, okay, I feel it, it's okay. So we could say, and just jot this somewhere, I just want you guys to start to see the relationships that we can notice, right? We were talking yesterday about relationships between quantities. We know this is 5 feet shorter. This is 32 feet longer. But every time we add 10, think about it. Give me your eyes up here for a moment. When we add 10, we add 10 here. We add 10 there, and we add 10 there. So every time we modify the one side length, we're really adding 30 overall. We could, depending on what our start value got us, now we can't quite get there because all my numbers keep ending in 7, right? And I need my number to end in 3. But we could use that pattern to help me get where I'm trying to go. Does that make sense? To recognize patterns anywhere we can? Now, that is not a formal part of what we needed to do here, but I want you guys to be working to recognize patterns anywhere you see them. Even if it's not that important, or if you think it's not that important, I want you to see that pattern. We did that together. All right, try this. I wanted us to have a little bit of time. I'm going to let you guys work. Is the back of yours another 5D? Yeah, sweet. So those we are going to use today. So flip this paper over. Back, like, I did not pick up one of your handouts, I guess. You should have this on the back. Oh, well, you can't see that. You should have this 5D on the back. Is yours super blurry? It should be super blurry.
Yeah, mine's totally blurry.
I'm joking. All right. So, everyone have this? We good? Here is our situation. Crap. Looking all over the place. Laura takes very good care of her vehicles. She owns a blue van and a red truck. Good vehicles now. Although she bought them both new, she's owned the truck for 17 years longer than she has owned the van. If the sum of the ages of the vehicle is 41, sum of the ages is 41, how old is the van and how old is the truck? Now, you have a 5D sheet in front of you. You have about 10 minutes left in class. You could guess check your way to trying to get where you need to be. You could, my suggestion would be, try to figure out variables and expressions to represent these values and work an algebraic process to get you there. I don't actually care what you do. I just know what will be easier. So if you want to guess check and you have fun with that, go for it. If you want to do the algebra, go for it. I'll check back with you in a couple minutes. Okay, because we have time, I'll go ahead and say, let's everybody do 2 trials of guess check, just to have some fun. Doesn't matter if it's like close or not, just guess check. You know, together they're 41, there's a difference of 17 years old, the difference of 17 years. Everybody guess check for a couple. You can draw a model. So you should be listing out what you know. So if I were, now you wouldn't have to have the top one that I have, but just something I think of immediately is, okay, the van's younger. If the truck has been owned for 17 years longer, the van's younger. If I try to draw a picture for this, I don't have an idea how to do a picture. But I don't even need a picture of a car. Right? What are we talking about? We're talking about cars? We're talking about years, right? So what if I did something like that? The sum of them is 41, right? Now your picture could totally be different, right? Again, I'm not an artist. But then I need to break this up, right? Because I have two different vehicles. Which one would get more of the line, the van or the truck? Which one would get more of this line, the van or the truck? The truck, right? It's older. So if I say, all right, here's going to be my van, and here's going to be my truck. Now, it may not be completely accurate for size, but it at least shows me that we have a little split. Now, is there a way that I can relate the van and the truck? Okay, let's do a couple guess checks, then we'll come back to this. Let's guess what if the van is, how much should the van be? 12, sure, love it. 12 years old.
I'm older.
Which means how old would the truck be?
29.
12 plus 17, so 29. To total the truck and van, 12 plus 29. Okay, you guys are cheaters.
I got that.
Yay. Good for you guys.
So, you guys are cheaters.
No, we're not.
Okay, no, we
Allie just got really defensive. I think that's the first thing you've said all class. No, we're not. Okay, so if I wanted to guess check like 10 years. Now, you don't have to do this with me. I'm just trying to show you the process. Hold up. Trying to show you the process. If I guess 10, then my truck age would be 27, right? And I know that my total, then I'm not going to show out all the work. I add them up, I get 37. When I look at is the sum 41, it's too low, right? If I had 37 and I need to get to 41, give me your eyes for a second. I want to show you, if you can't think up the algebra, and I think some of you guys can't, some of these situations, guess check is your only way. Actually, I had a couple math counts kids yesterday who were like, I think guess check was the fastest way to do this. Like, sometimes it is. So then, since 10 was too low, jump up by however much you want. I would probably jump to 15 next, if it was me. I'd then have to add 17 to that. So I'd get 32. And now I go, okay, 47, this is too high. So I know I have to be between 10 and 15. So then I start guessing values between 10 and 15. And I could get to 12. Now, the problem is that would still take me a couple trials unless I get lucky. I can do this algebraically, and it would only take me one try. Even if these aren't whole numbers, I could do it in one try. Anyone know how to work through this using the algebraic process, variables and expressions? Grant?
So I started out with truck. I had T for truck and V for van. So I had truck equals V plus 17.
Ah, love it. So, Grant had T is our truck, V is our van. So I'm going to put V up here. But then he said truck is actually V plus 17. So we can have, and you can put this in trial 3 or something, wherever you can fit it. Please get this on here. This is the more important stuff to have down. We're going to give van a variable, V. We then relate that, knowing it's 17 years old. So do not use two different variables unless you have to. We want to use the V for both. Then when I go to add the truck and the van, I'd have V plus v plus 17. But really, what do I have? Allie? You were just saying. I have v plus 17. What's v plus v? 2v. So I got 2v plus 17. Sorry, I'm going to steal some space. You probably shouldn't be writing this out here because you already wrote stuff, but I just need to steal some space. We could then say 2v plus 17 equals what? What's the sum of their ages? 41. Following that algebraic process to work towards getting v by itself, what do we do first here? We want to try to isolate v, but before we can isolate v, we've got to isolate 2v. So what do I need to get rid of? Emily is not here still. Eleanor, what do I need to get rid of? How do I do it? So please show this on your paper. We're going to get rid of that 17-year difference. So if we just had double the Van's age, what would that be? That subtraction gets you 24, right? And to go from 2v to just v, or we can say 1v, we divide by 2. And that's how we use the algebraic process. Alright, here's what's up. Here's what's up. Hold on. While you pack up, you can do it with your mouth closed. So, we do not have class tomorrow, which means we do not have new homework, which really means you only had 3 homeworks from this week, and homework 1 already got checked, or should have gotten checked. Check math. If you never turned in your math journal, you got a missing on there. A couple of you guys have blanks because you were absent, or I might have put missing without an effort mark, which means your effort didn't get hurt by that. I'm going to do a homework check, myself and Mr. Smith, Monday or Tuesday. So please have that stuff done. There's no reason not to. You got A1 extensions today. You got time tomorrow. You got the weekend. Tonight's homework's only 5 questions. So please have that done so we can talk about any issues on Monday, Tuesday. Hey, hold up. I need attention for a second. I still actually have like a minute. I need butts in seats. Who went into school with me yesterday? Anyone go into the math page?
Yeah.
Anyone notice anything in the math page? I am going to, again, I'm going to hope that people don't take advantage of this like in a bad way. I'm, again, going to start posting answers. And actually, I made a decision when talking to my high school class. I'm going to post the answers from the lesson and the homework. For kids that if you miss the lesson, you've got the answer key for the lesson. But you need to, once your homework is complete, check your answers. If they're wrong, I'm not telling you you have to redo it. You need to ask me for help. Or ask somebody, right? Check your answers every day. I'll update that day's stuff. Thank you very much. Have a great day. Oh, no. That's rude. Because people need to check their answers and make sure that they did it right.
Yeah, they can just text you.
I mean, I can see where you're going with that,
Yeah.
but it's a little mean.